Hello everyone and welcome to today's webinar, the CANSO Academy, How to Improve Aviation Efficiency Through Remote and Digital Towers, part 1 of the series on guidance materials. Before we get started, I'd like to go over a few items so you know how to participate in today's event. You may have joined the presentation listening using your computer speaker system by default. If you would prefer to join over the telephone, just select phone call in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentations. It is my pleasure to introduce you to Colleen Harisco, the Operations Program Manager for CANSO, to kickstart the proceedings. Colleen, I hand it over to you.
Thank you, Helen, and good morning, good afternoon, good evening to everyone attending this webinar. Thank you so much for your interest and your participation. Again, as Helen indicated, if you have any questions, please type them into the question pane at any time, and our team will answer them at the end of today's webinar. Just a couple of notes, a couple of thoughts about the Operations Standing Committee that CANSO hosts. There are 10 work groups now. We have Aeronautical Information Management, Air Traffic Flow Management, Data Link Implementation, Environmental Operational Performance, Performance Navigation, Performance-Based Navigation, Unmanned Aerial Systems and Emerging Technologies, UTM, and a new group that was set up last year is the Swim Work Group. And we have quite a few members who are always looking for more. And that, of course, is in addition to today's task force that is hosting and running this webinar, the Smart Digital Tower Task Force. So if you have interest and time, we welcome you to any of our work groups. You can find out more information by emailing me directly or by emailing info@canso.org or looking at our website, mycanso.org, for more information. Always happy to have new faces, new thoughts, new ideas. Don't feel like you need to be an expert in the field to join. Sometimes it's the people that are asking questions that push us to the next level. So we welcome your participation. Thank you for joining today on how to improve aviation efficiency through remote and digital towers, part of CANSO Academy's 3-part webinar for the implementation of remote and digital towers. We welcome you very much. And without further ado, it is my pleasure to introduce today's moderator of the webinar, Connor Mullen. Connor is co-founder and managing director of Think Research, the UK ATM and airport consultancy. For the last 12 years, he has specialized on remote and digital towers, supporting research and implementation projects worldwide. Connor is also the associate member representative on the CANSO Executive Committee. Without further ado, Connor, you have the floor. Thank you.
Thank you, Colleen. And can I offer my own welcome to the several hundred of you tuning in? It's big numbers. This guidance material has the potential to be a real benchmark for digital tower projects to use. It's the first comprehensive and publicly available document of its kind. And as moderator today, I'm not going to do too much talking. In fact, I'm going to hand you straight over first to the 2 co-chairs of the CANSO Digital Tower Task Force. That's Nicholas Gustafsson and Rory Hedman. Nicholas and Rory will provide a general overview of the guidance material. And once they've done that, we have a further panel of experts to give more detail on various aspects of the guidance material. I'm sure most of you will know Nicholas already, but Nicholas is Vice President of Business Development and Government Affairs for ESTATS, who are the joint venture between Saab and LFE, and they operate, among others, the Swedish remote tower centres in Sundsvall and Stockholm. Prior to joining SDAS, Niklas held various managerial and directorial positions with LFE, and he is, of course, the co-chair of the CANSO SDT, Smart and Digital Tower Task Force. Niklas will hand over to Rory Hedman, who's a senior consultant at Think, and Rory's again worked on a wide range of digital tower projects. Along with myself and partners with LFE, he co-authored the original CESAR operational concept, which became a real reference document for everybody else wishing to implement it. And in 2016, Rory was, we believe, the youngest recipient of the EuroCAI Award for outstanding contribution due to his work on EuroCAI Working Group 100, again on remote towers. And Rory is the other co-chair of the CANSO Smart and Digital Tower Task Force. So, Niklas, I'd like to hand the floor to you and Rory, and I hope everybody enjoys what they're about to hear.
Well, thank you, Connor, for doing that. Yeah, the task force has now been in various forms for almost 3 years, and when we started, it was a small group trying to look at how the safety impacts and security and so on. But then, after a year, it was clear that what was needed was more like a guidance for those who's trying to figure out how this is going to be used and what are the key critical aspects of going remote or going digital or smart, whatever you pick and choose. And I think last time we checked, there was about 50 people participating in the task force, which I think it sort of reflects maybe the way the interest goes here. And having worked with this over the years, it's clear now, I think, that we have had the innovators, which we've been part of, many of us, and the early adopters are there. We're still in that, where you're trying to achieve and understand. And I think the guidance material is quite timely here now, and I think that's been also the outset when we work through this. This sort of, there's a jump to take for many, where you are going to more sort of using it in a standardized fashion. And I hope sincerely that the guidance material will help to take that jump or make that jump for many, both operational, technical, but primarily also companies who need to see and understand how this. And before I hand over to the content, I think one of the biggest thing I've seen, being part of this, is that it's not just a technology. It's very much a change of things, to change management, and it will have an impact on your organizations, because you can do new things and you can work differently. And even if there's sometimes a resistance in the beginning, there's almost always smiling faces when this is operational. So that's time to take the jump, and the guidance material will be a help to make that happen. That's my strong belief. And over to Rory then, who will go into the details of the work done.
Thank you, Niklas, and hello to everyone watching. So to start, as Connor said and as Niklas said, I'll be providing an overview of the recently published CANSO guidance material for remote and digital towers. I'll be outlining the structure, showcasing some of the key content and providing some of the thinking behind the guidance material. I'll then hand over to some of my colleagues who'll be able to go into some more detail on some of the specific sections. So the guidance material provides an easily digestible overview of some of the key aspects of the operational concepts and technologies involved for those new to the concept. The document also considers what drivers, challenges and pressures can influence operations and ultimately the decision to implement. We structured the content around 5 specific questions that ANSPs may pose when considering a digital tower implementation. So that's: what is digital tower? Why implement a digital tower? How to implement? Why implement a digital tower? When to implement? How to get started? And finally, what is next for digital towers? The information within the guidance material considers real operational experiences and the lessons learnt by the early adopters of the technology. A series of case studies are also presented, provided by CANSO members who have digital tower implementations. Next slide, please. The guidance material starts by considering what is a digital tower. Digital tower is an extremely dynamic concept. Those of you familiar with the content will be well aware that even defining the terminology to be used to refer to it has been hard. This is because the modes of operation and technologies that can be combined together and referred to as a digital tower are far from fixed. As such, currently there is no universal definition of digital tower. However, within the guidance material, we consider that the concept is one which enables the provision of aerodrome air traffic services from any location. This definition is the most stripped back definition we could arrive at. It focuses in on the most fundamental aspect of the concept, the decoupling of aerodrome ATS from the physical airport location. The guidance material then extends upon this basic definition to highlight another key aspect of the concept, that digital towers enable operators to survey the aerodrome and its vicinity using digital means, either instead of or as well as using the naked eye or binoculars. The early concept development history of remote and digital towers is also outlined within the guidance material, showing how concept understanding has evolved over the past 10 years, from the early R&D projects right up to the current understanding we have today. This has seen the view of the concept change from a relatively narrow view of a concept suited only to low traffic and low complexity environments, to one which encompasses a range of operating modes, is not restricted to specific operational environments, and offers a high degree of flexibility in terms of how the concepts can be applied. The guidance material reinforces the message that digital tower solutions should be tailored to specific operational environments to meet the specific operational requirements. The document discusses factors to consider that may also influence the most suitable technical implementation. Next slide, please. The decision to implement a digital tower will be based on a balance of business decisions, which consider costs, benefits, risks, and rewards. The document outlines some of the key benefits, challenges, and considerations, all based on actual experiences of early adopters using a variety of different digital tower technologies and applying them in different operational environments. Benefits broadly include cost efficiency, increased flexibility, operational resilience and contingency, increased level of service provision, support during LVOs, and the list goes on. However, challenges do still exist, and depending on the specifics of the implementation, can include reduced stakeholder acceptance, and the initial cost of the business case still being relatively high and sometimes difficult to justify. Next slide, please. So 4 case studies have been selected to emphasize the diversity in digital tower solutions and applications. These are just listed on the slide. Each one offers a unique insight into the drivers, challenges, and lessons learned along the way. The task force members felt specific case studies were important, as the intention is for ANSPs to be able to identify similar operational environments and conditions, and as such better understand the aspects that may apply to them. Broadly, the case studies showcase the following scenarios. So existing or newly built airports that do not have a conventional tower, small airports where the benefits of a centralized resource is desired, airports which require a contingency aerodrome control facility, and airports where the conventional tower is approaching its end of life. I won't be discussing the case studies in detail today. These will be the subject for future webinars in the coming weeks. But our hope is to expand these case studies further in the future to continue to demonstrate the diversity of digital tower solutions as we see more implementations in the future. Next slide, please. So as shown, these are some of the events that can lead an ANSP to start to consider a digital tower program. Some of these were mentioned previously and are explored in the case studies. These events provide an opportunity for ANSPs to assess cost benefit, where the option to implement a digital tower is assessed against other options. It may not always be the case that a digital tower is preferred, but these are some of the scenarios where an ANSP may want to consider investing in a digital tower solution. For example, a conventional tower reaching the end of its life may be an appropriate time for an ANSP to consider an implementation. However, in this case, building a new conventional tower building is also an option. Likewise, if an ANSP is set to invest in many different new tower systems, then a digital tower may offer improved system integration and working position display. As such, this may also be a good opportunity to just start evaluating if a digital tower is appropriate. Making the business case for implementation stack up can be challenging. The wider benefits and challenges discussed in the guidance material, therefore, should be considered, helping the ANSP to take a longer, more strategic outlook. The driver for implementation will also have a material influence on the end solution, influencing, for example, the location of the digital facility, the operational modes used for each airport, the level of benefit that may be achievable, and which technologies may be required to realize those benefits. Next slide, please. Getting started with a digital tower program can be daunting in an environment where there is no firm framework for implementation and a constant spotlight on the concept. The guidance materials discusses some important aspects to consider and understand before getting started. These include understanding the status of regulatory consultations and any updates to standards that pertain to remote and digital aerodrome ATS, understanding the aspects to consider when seeking operational approval, including safety assurance, human factors, validation, the recording of data, licensing, and training, and other business aspects such as facilities, locating infrastructure, security, both physical and cyber, change management, and transition. So I'll now hand over to some of my colleagues who will be able to go through some of these important aspects in more detail. Thank you for listening.
Thank you, Rory, for the overview. I do recommend anybody that hasn't already read it to have a look at it. There's a lot in it, albeit in only 47 pages. And to take you through some of the more detail in that, we're now going to move on to our extended panel of experts, each of whom will give a brief 5-minute overview of some of the specific considerations outlined in the guidance. We're going to hear from Rolf Zahn of NLR, Zoltan Molnar of Hungarocontrol, Matthias Abel of LFA, and then Sarah McClarty and Elizabeth Pavlova from Think. As you can see on your screen, we're going to begin with Rolf Zahn. Rolf is Senior R&D Manager and Human Effectiveness Specialist within the Training, Human Factors and Cockpit Operations Department of NLR, the Dutch Research Laboratory. Rolf's research centers around several topics, all of which are very relevant to digital and remote tower, including cognitive psychology, human factors, HMI design, situational awareness, workload usability, and many, many more in a long and distinguished career. So, Rolf, I'd like to hand over to you.
Thank you very much for the introduction, Connor. Can we move on to the next slide, please? Yeah, thank you very much. Well, what I wanted to talk about is the human factors aspects of remote and digital towers. What I think is that if one confronts controllers with a new situation, with any new situation, of which remote towers are an example, their work may be influenced, they may be influenced. And what we think is that it is possible to pay attention to that prior to installing the system. And if you do that, you can have facts, you can have data, and you can use those to discuss with the controllers within your ANSP what the real changes are that happened and what is basically hearsay. So that is why I plead to do some human factors measurements in case of any uncertainties prior to installing your system. You can see on the slides that there are numerous human factors that you can measure. Later on, I will be more clear on which human factors in particular can be measured. Can we move on to the next slide, please? What you see here is that one of the things that can be done is human-in-the-loop simulations. And you can do that to specify the requirements of your operation and your function. You can test out precisely what you want to do with your new system. You can determine the impact on as well the operation as on the working environment, as on the human performance. All of those can be measured. My presentation now is primarily on the human performance, of course. You can validate that new situation. So you can test it in all possible ways and gain data about if the new situation is an improvement and where it is an improvement, what will be improved and how are the humans influenced. You can also use simulations, by the way, to train for a hazardous situation or to train your controllers to get used to the new situation. All of that is quite important to do. And as you can see here on the picture, you can have a simulator. This is one at the ATNR, where you can have a multiple remote tower setting and test it all out. Can we move on to the next slide, please? Here you see a number of human factors constructs that are often relevant to take into account, to measure, where you may have questions about. Questions can be, will the controllers be distracted? Will they always be able to look at the right displays? How is the distribution of attention if they have monitors in front of them rather than a big window? How did they use the pen-tilt zoom camera? So that is a question that you may have. Another question that you can have is, how will the situational awareness be influenced? Will controllers still be able to have the same level of awareness as they used to have? You may want to see if workload is influenced. If you add extra airports in a multiple remote tower situation, or if you have other changes, you may want to see what that does. Fatigue. People may be fatigued because of the different way of working, looking at different displays, and the stress level. Maybe that people are concerned or anything. So those are human factors constructs that can all be measured. If you're interested, I would be happy to talk about that later in more detail. For now, I want to say you have measurement devices, and those measurement devices can be applied to measure those constructs, and you can use the devices dependent on the situation. In real life, we have done experiments where we used eye tracking as well as heart rate measurements in a traditional tower and in a remote tower, and we compared both situations, and that can give you a really good feel what's going to happen to your controllers if they move from the traditional tower to the conventional tower. All of those, and what you can see is that all of those different measurement devices can indeed be used to make different statements about the different human factors constructs, so they relate. Further, what you see here is that it is basically biobehavioral data on the screen. It is not subjective data, not questionnaires, not performance data, not the amount of aircraft being handed over. Those data are needed as well. That is what we call methodological triangulation. If you take them all together, you can make the most complete and detailed picture of what's going to happen to your controllers. And on the picture, you can see what an eye tracker and an heart rate measurement do, how they look like if you put them on the controller, and that the controller is still able to do his work while you do those measurements. That is what I wanted to say about human factors measurements, and now I want to hand back the controls to Connor. Thank you.
Excellent. Thank you very much, Rolf. Our next expert is Zoltan Molnar. He is an ATM safety and risk management specialist at Hungaro Control. Zoltan is responsible for the safety assessment of Hungaro Control's remote tower program in Budapest, and he also plays a pivotal role in their remote tower related consultancy and R&D activities. Zoltan is active in other ATM projects, for example, cross-border free route, airspace implementation, and participates in various ATM safety monitoring activities and artificial intelligence safety working groups. So welcome, Zoltan, the floor is yours.
Thank you very much for the introduction and good afternoon for everyone. I would like to share you some thoughts about the safety aspects of remote towers, mainly the safety assessment process, safety benefits, and safety issues of remote towers. Next slide, please. So although the remote tower implementation project is a quite complex project, there is not a specific safety assessment methodology is needed for the safety assessment of remote tower projects. Here in Europe, we are using the methodology provided by the Regulation 373, but all ANSPs can use their own safety assessment methodology, of course, which are compliant with the ICAO regulations and the local regulations. There is also another guidance material which can support the safety assessment, but Matthias will speak about it in the next presentation. The most important steps of the safety assessment process can be seen at the bottom of the slide. And next slide, please. From the safety benefits of remote towers, maybe the most important is the flexibility. So the conventional tower, the position of the conventional tower is more or less given in an airport. But as airports become bigger and bigger, some points of these airports can be quite far from the conventional tower. A well-designed visual surveillance system can provide a better view, even the furthest point of the airport, and it is much more flexible, much more adjustable in case of later airport development. Very important is the integration of the visual surveillance system with other ATM systems like the ASM GCS, which make it possible to provide tailored information on the panorama or video wall, like labels, for example, aircraft labels and vehicle labels, which can be very helpful for the air traffic controllers. Filtering functions can enhance image quality in case of low visibility conditions based on infrared or thermal camera technologies, and image recognition can also support additional functions and safety nets, for example, to mark moving objects like pedestrians or vehicles in the maneuvering area. The next slide, please. What about the safety issues of remote towers? The biggest novelty, or one of the biggest novelties in this technology, the visual surveillance system. So we have to really understand what the air traffic controllers would like to see to provide service safely and efficiently. And based on that, camera locations, camera types, orientation, and redundancy can be defined. Orientation is a very interesting question and very important in case of bigger airports and distributed camera system, but it can be important in small airports as well. The question of visual presentation, the type of it, if we choose a video wall or a panorama, size, arrangement, and overlays of it, like I mentioned in the last slide, is also an interesting question. The controller working position and the visual surveillance system HMI should be also assessed and evaluated based on human factor requirements to provide good system for the operators. And the network, which is also very interesting because remote towers are usually not located within the airport, but can be located very far, hundreds of kilometers away, which adds extra network connections, extra interfaces, which should be evaluated. Software safety aspects of visual surveillance system software are also an interesting part of the assessment. And Last but not least, degraded modes should be evaluated. Loss of elements of the visual surveillance system, loss of cameras or screens, freezing of camera or screen, or freezing of a picture, and quality problems can be also aspects of assessment. So all in all, there are no two identical remote tower implementation projects. The weight of these issues is highly depends on the local operational environment, but it should be said that proper safety assessment is very important in case of every remote tower implementation. And with this, the remote tower operation can be safe or even safer than the conventional tower operation. Thank you very much.
Excellent, thank you, Zoltan. Now, the next stop on our whistle-stop tour of the guidance material is back to Sweden, to LFV and Matthias Abel. Matthias was another one of the crew from LFV involved right back at the very start. He has been involved in remote tower-related activities for over 10 years, including concept development, research, implementation, and standardization. And of particular relevance today, from 2015 to 2018, Matthias was seconded to EASA, where he led the EASA remote tower rulemaking task during its second phase, which of course led to the publication of the current EASA material on remote towers. Matthias, albeit back at LFV, I think, is now participating with remote towers with ICAO, as well as continuing the EASA rulemaking activity and representing CANSO. So thank you, Matthias, and we look forward to hearing what you have to say.
Thank you, Connor. Thanks for that. So hello, everyone. I'm going to give you an update and regulatory outlook on the standardization and regulatory activities as concerns remote and digital towers. So I will talk briefly about EUROCAE, EASA, and ICAO work related to that. So we start off with the EUROCAE and the technical standardization part. So EUROCAE has a working group 100 called Remote and Virtual Towers that's been active since 2014, which includes representatives not only from Europe but from around the globe, in fact. And what you see on the right side of the slide now is the current minimum aviation system performance standard for remote tower optical system that was published in end of 2018, which, well, includes technical requirements on the remote tower optical system. Basically, there is further work planned, as you can see on the last two bullets. I think we should go to the next slide, though, to keep up the pace in the presentation. So next slide, please. So more on the regulatory side, EASA, the European Aviation Safety Agency, has been active since 2014 as well, and with rulemaking task looking at remote towers. And there is a rulemaking group connected, which includes representatives from around Europe, including mainly NSPs, CAAs, and unions. The current material that EASA published is guidance material issue 2, which you can see on the right side of the slide again, was published beginning 2019, which is, you could say, complementing the applicable regulations and international standards on aerodrome ATS in the remote context. There is also a set of acceptable means of compliance and guidance material complementing the so-called ATCO licensing regulation. The work continues. EASA is continuing its rulemaking task, and updated versions of this EASA material is expected by end of 2023. That's for EASA. And please, next slide. Which is about the work within ICAO. On the topic, so in end of 2018, ICAO Doc 4444, PANS ATM, via Amendment 8, introduced support for remote ATS. And following that, based on requests and feedback from several states as well as organizations, the ICAO ATM Ops panel initiated the work for the ICAO Remote ATS subgroup, which is now looking at making a gap analysis to see if there is any need to provide further ICAO provisions on regarding remote ATS, and is likely also going to produce ICAO-specific guidance material on remote ATS, subject to the approval of the ATM Ops panel. In parallel to that work, what can be mentioned is that there is another subgroup working on an update on Doc 9426, which is the ATS planning manual. And this update and the new Doc 9426 is likely going to include a new section, which is looking at remote ATS. In fact, that section is already drafted, and there is a draft available on that section awaiting approval by the ATM Ops panel. However, in general, the work on the update of the Doc 9426 is so far on the initial stage. So this work will take a few years before it's finalized, absolutely. And then one more slide. So next slide, please. So basically, very short, in conclusion, what can be said is that, well, what can be good to know that there are, in fact, already technical standards and regulatory support available at this moment, and this they will be fine-tuned and developed further along the road here. So that's basically my main message today. Thank you, everyone, for listening.
Thank you, Matthias, and I appreciate you attempting to keep up the pace there. The document Matthias refers to is, of course, referenced and indeed hyperlinked in the references section of the guidance material if anybody wishes to find it more easily. Next up, we have Sarah McClarty. Sarah is a senior consultant at Think, and she specializes in concept development, validation, and simulation. Sarah has worked on many projects from early maturity ATM concepts, validating them all the way through to implementation. That's across the on-route, TMA, and airport operational environments. Sarah led many of the early remote tower validation programs in Sweden and Norway, and was then seconded to Avinor to assist in their remote tower system procurement. And Sarah has worked on projects across Europe and the Middle East, and today she will talk about remote tower validation. Welcome, Sarah.
Thanks, Connor, and hello, everyone. So as Connor said, today I'm going to share my insight into how validation plays a vital role in remote and digital tower implementation. I could spend an hour talking about this, but I've only got 5 minutes, so I'm going to whittle through it quite quickly. And if you have any questions that don't turn up in the Q&A, please feel free to email me. So first of all, what is validation? So validation, it's a key component in a concept's journey towards implementation. It's important to understand exactly what it means so we can exploit its importance. So different stakeholders will focus on different aspects of the question. Regulators might focus on if a remote and digital tower is safe. Controllers, on the other hand, they're obviously interested in safety as well, but they might also be interested in appropriateness or fit for purpose. The EACVM, which is the European Operational Concept Validation Methodology, it was developed to create a validation methodology to help us establish what role validation plays during ATM concept development and communicate this to stakeholders. So it basically defined it as fitness for purpose of an operational concept. So validation is a critical part of the approval process. Without a proper validation process, the chances of getting a remote tower system, which is a very complex system, into operations is going to be reduced. Why do we need validation? People often focus on technical or functional requirements and verification-based acceptance of these requirements. Often factory acceptance tests and site acceptance tests are typical end of cycle milestones. However, this is verification, it's not validation. Verification is, are we building the system right? Whereas validation is, are we building the right system? So verification might be the remote tower has this function or this button, it supports this many airports, whereas validation is it acceptable to the user, is it safe? So all obviously site acceptance tests and testing is an important part of the process, but several validation cycles are needed in addition to get into operation successfully. And projects have often stalled by not incorporating a validation process into implementation planning. Next slide, please. So what validation techniques do we use in remote tower? Well, it depends on a variety of inputs, such as maturity, type of evidence. Normally, we write all of these inputs in a validation strategy at the beginning of a project, so we can tick off as many requirements and objectives as possible, and to help identify the best validation techniques to use in the cheapest or most suitable manner. Some examples are listed on the slide. So you've got workshops. These are really good at engaging stakeholders early on, helping with user acceptance, but these are subjective based. Then we've got real-time simulations. These are good for testing a wide range of operational scenarios, such as different traffic, different weather, emergencies. Also, it can focus on iterative development of technical enablers, such as operating modes, operating procedures, for example. However, the main downfall of RTS is that it's using synthetic visual presentation. So you're not generally using the live feeds from the airport, so it's limiting the suitability to assess digital tower visual sensor presentations, which generally is a critical factor. We also have shadow mode trials. There's different types of shadow mode. There's passive, active, advanced, giving different levels of control to the shadow team depending on the type of trial. They're really good at assessing if the system performs as expected in a live environment. However, you can't test all of the scenarios that you would be able to test in a real-time simulation. And then you've got live trials. These are really realistic. You're exposed to reality. This is often leave to the last technique that you would use just because they are expensive. Next slide, please. So what lessons can we take from the CANSO guidance material? So we have a series of case studies in the CANSO guidance material. If you have a quick look through them, they generally emphasize on stakeholder involvement and the need for that, the time required for approval, and the need for human performance acceptance and assessments. These are all covered if you incorporate a validation process and a validation strategy within your digital tower project. So it's really important to do this, and if you do this, you will have a greater chance of success and avoid time and cost overruns. Thanks, Connor.
Thank you, Sarah. We really are whizzing through this. I think this is why we've made the wise decision to put this across 3 parts so we can try and cover as much as we can. Our next and final panelist is Elizabeth Pavlova. Elizabeth, again, is from Think. She's an air traffic management consultant specializing in remote towers and fast time simulation. Elizabeth has published several articles on remote towers and future concepts, and she maintains Think's frequently referenced remote tower resource map. Elizabeth made a significant contribution to the development of the guidance material for remote and digital towers, and she's here today to talk about the next steps. Thank you, Elizabeth.
Thank you for that, Connor. Hello to everyone who joined us today. And as Connor mentioned, I'll be going over the final section of the guidance material today, which focuses on talking about what is next for digital towers. We can move to the next slide, please. As we all know, technology and technology concepts are continuously evolving and becoming more complex. Therefore, it is crucial for digital towers to be scalable in order to adapt to those changes. Such advanced technology and technology concepts that are still in their development stage are thought to be of great importance when deployed in challenging operational environments. And such solutions do have the potential to provide benefits to the digital tower and are primarily concerned with the ability to integrate and share more useful data, to enhance performance in specific areas with significant importance to maintain the safe, efficient, and reliable operations, to provide advanced conflict detection solutions, to enable forecasting and novel ways of visualizing information for the operators, as an example, augmented vision, and to provide more integration of digital towers with the other air traffic system. If we can now move to the next slide, please. When we think about large-scale digital tower centers, that is already an existing operational concept. An example is the Avinor's remote tower center, which is located in Bodo and became operational in October 2020 last year. And we're hoping to learn more about this use case in the future updates of the CANSO Digital Tower Guidance material. The opportunity here for the large-scale digital tower center is to increase the maturity of the concept and the implementation numbers in the future to ensure that performance and efficiency benefits can be delivered, some of which include improving the flexibility, increasing air traffic service availability, providing new operational concepts, and of course, improving the business cases. However, it should be noted that there's also challenges and differences that should be considered, and some of those might include the introduction of new roles into the business, the need for integrated training of the controllers, the need for increased coordination, and of course, the introduction of new dependencies into previously independent airport operations. We can now move to the next slide, please. Another hot topic in the industry is the UTM-ATM integration, and digital towers here present an opportunity to support a growing UAS presence and could result in improving safety with the use of digital safety nets and object tracking technologies. They can ensure operational continuity. They can allow instant information sharing on UAS presence, which itself would improve the situational awareness of the operators. When we talk about the next steps for the digital towers, this is to look into enhancing the aerodrome air traffic services and increasing the coordination and information sharing between aerodrome and other air traffic services, such as approach and area service. The CANSO Smart Digital Tower Task Force will continue its work, and it will be updating the guidance material accordingly to reflect the advancing of the digital towers technology and to include further use cases that can benefit and showcase the variety of business cases and implementation options that digital towers are used for and could be used for in the future. Thank you very much. I will now head back to Connor.
Thank you, Elizabeth, and thank you indeed to all our panelists. I don't think many of you have ever spoken so fast. We are now going to go to some question and answers from you who are listening. If you haven't already and you wish to do so, please use the question function on the control panel of the GoToWebinar platform. Before we do, I would like to remind you, this is the first of 3 webinars in this series, where in this webinar in particular, and also I guess for the in order to target your questions, we're focusing really on the guidance material itself. We will have time to answer technical questions in part 2 and look at case studies and key learnings in part 3. So today, if you do have a question about the guidance material itself, please feel free to ask that, and we'll attempt to answer those today. So I'm looking at the questions here on my screen, and if I can start with, that was the very first question we got asked, and I guess this one is maybe to Matthias. And the question is there any ICAO provision for supporting remote towers operations? So if you can just very briefly again, Matthias, what are ICAO doing here in terms of guidance and support?
Right, thanks, Connor. So again, ICAO Doc 4444 was updated in 2018 and introduced some support for remote ATS, which is already included. And in addition to that, as I mentioned, there is a ICAO subgroup currently working on a gap analysis to see if there is any more need for provisions in the existing ICAO SARPs, and potentially there will in the upcoming years also be a ICAO specific guidance document, but it's not decided yet. So that's the situation today.
Thanks, Matthias. Our next question then, and it's a good question. It's one that I think we've asked ourselves, or you'll have asked yourselves quite a lot over the years. And I'll read it here and give me your comments on. And it says, sometimes it is called digital, sometimes remote. And these synonymous terms now. And a point which I have to agree with, the invention of the vague term digital did not really improve our situation. So I'm well aware, in the course of this webinar, I probably referred to it as 3 different titles: remote, digital, smart, and all sorts. I mean, in writing the material, you had to pick one. You had to back a horse. So maybe Nicholas and Rory, what's the definitive term these days? What would you recommend everybody start to use?
Well, Nicholas here, I think taking the approach that not to be so precise on this. There's always there was a discussion if it's remote, or it could be 2 meters apart from the existing tower, or it could be 1,000 kilometers, as you say. And I think what Rory said in the beginning, that it's something you can actually physically, you can detach. You're not linked. You can use sensors rather than having sitting at the site. I think that's basically the idea of remote and the digital towers and so on. I think probably we'll see this will evolve over the time and find other ways of expressing it. I cannot say anything. Digital is very, very broad, and remote has its point. So I think we just could stick with this. This is a transformal thing that you can actually decouple the physical presence of individuals from the airport to somewhere else, and then you can centralize this and so on. I carefully avoided going into this debate because it never ends.
Anybody else want to keep the debate going briefly?
Yeah, I mean, I agree with what Nicholas said. In the guidance material, we took a decision to use digital tower as the term, which it is not necessarily aligned with what's been used in other guidance. EASA don't use the term digital tower, but I think that what we were trying to do was just move beyond the debate of remote not necessarily being the most suitable word for all implementations. I do feel like digital tower is a slightly more user-friendly, informal term. It's all-encompassing, but it is worth noting that it isn't the term that's used throughout all of the standards and guidance, but probably not to get hung up on that. And that's why we included the concept history in the document, because we do think it's quite important to still have that story to understand the terms.
Okay. I guess maybe this is a classic case where we could have had a poll running along the side, remote, digital, or both, or neither, in fact. If I can move quickly on, so the next question, I'm going to phrase it maybe slightly differently to how it asked. The question itself was probably referring to some of the stuff that you spoke about, Rolf, and it was, have any results of the human factors studies been done, maybe not just specifically by yourself, but anywhere? Have any of those results been published? And my initial comment before I hand over to Rolf is that in our own experience, there's very little publicly available that you can access quite freely if you're not part of a project or a program like CESAR. And for me, this was one of the drivers of the guidance material, to make something that was genuinely, Google and download it and away you go. Because there are not many references quite like that. But in terms of the human factors studies, Rolf, are you aware of any publicly available results that people can reference?
Yeah, well, What you pointed out already, CSR-related work sometimes is publicly available, but and there are presentations. I've given some presentations myself at some conferences where you can find from which you can find the proceedings. So if you Google, that's just a brief answer for now, you will definitely find something. And if you want more support and more concrete things, feel free to email me, and I would be happy to help you further. But as pointed out correctly by Connor, a lot of the work was executed for an ANSP, and that of course is all confidential. But yeah, it is possible to find publications, and then I'll be happy to point them out to you.
Excellent, thank you, Rolf. We have a few technical questions, and what we might do is we might carry those over to the next webinar, because we have, I think, only a few minutes remaining. Some of you might have touched on this already, but in terms of the guidance material, it was launched in December. What are the plans for future editions, and what might it include that you haven't already included in this release? I guess I should aim that to Nicholas maybe and Rory first.
Yeah, I can start. I think it's as you saw, in an emerging technology and concept, and that I think that's logical that you do updates of the material. And I think what we've been talking about is, of course, when the operational experience grows, it's sort of like, first you have to prove that this works, and yeah, it works, it's safe, and the people can work on it. And then I think we'll be sliding more into the fact that, okay, how do you do this more efficiency? What are the things that provides the sort of the scalability aspects of having a center, or maybe even in a specific type of environment for small, large airports and so on. So it's sort of, I think it will just reflect the experience from growing from the first, yes, it works, to yes, this will works in a larger context, or in a country, or in a region. And I hope also we will see cross-border discussions going on as we move along. And I think that's, and I think Elizabeth also pointed to certain directions which you may find in the future of integrating new types of aviation scenarios. I hope that by next year at this time we may publish an update. That's at least an ambition as a co-chair of the group.
Yeah, definitely. And we're always looking to expand the case studies. So we have 4 at the moment, and those are, we called them early adopters. They're case studies that most people will be familiar with, but there are definitely other remote tower, digital tower implementations out there that I think would be really good for the CANSO document to include. So that'll be one addition I think we look to. And also just, some of the things that Elizabeth talked about, I think that they're branching into what we would probably call digitalization, and looking at digitalization of ATM and airports in a more general sense, of which remote tower and digital tower is one element. So maybe ultimately that's where the guidance material will go, including more innovative technology.
Okay, thank you, Rory. Another question then from the audience. Obviously, in guidance material, we want to be very positive, and you're a positive bunch. But the question is, what about failures? Does the guidance material address any failure cases? Technically, yes, but perhaps instances where, in trying to implement remote tower, things haven't gone so well, and therefore we've learned some lessons. So, like I say, we all try to be very positive and optimistic, especially in these forums. What can the guidance material tell us about, if you like, where we've been burned in the last 10 years?
I think I could start with that one, Connor. The guidance material doesn't directly cover failures, but what it does cover is the lessons that have been learned along the way. So the case studies are all quite transparent with the things that they've learned, and obviously with those case studies, ultimately they've learned the lessons and they've adapted to have successful implementations. But what the guidance material also does that I think might help with this kind of question is it outlines some of the considerations So what we've said is, well, when would you implement a digital tower? And as I was saying before, I think it is a balance of challenges and benefits. We outline a lot of the challenges that you do need to overcome. So I mentioned stakeholder acceptance, but there are some other challenges you need to consider, and they're things that may lead your implementation to not be successful at this point, and maybe it's sometime in the future, or maybe it's just not suitable at all. So I'd say have a look at those sections of the guidance material for a few kind of indications of things to look out for.
Okay. Anybody else want to add anything on that? Hearing none, we have reached the end of our allocated 1 hour time frame, I think. What we have quite a few questions. As I say, some of them are maybe more suited to the next webinar. But what I hope we can do, anybody that has asked a question, I'll make sure one of the panelists at least can answer it, potentially by email if we can't answer it during one of the webinars, if that would be possible. We'll have to check with our lovely friends at CANSO. So I think that's all from myself, and that's all from our panelists. Thank you all for joining. We're going to hand back now to Colleen, who will close the webinar for us.
Thank you, Connor, and a huge thank you to Nicholas, Rory, Rolf, Zoltan, Mateus, Sarah, and Elizabeth, as well as your employers, Saab, Think, NLR, Hungaro Control, and LFV. I very much appreciate your time and your effort and your expertise and all that you do, not only for CANSO, but for the remote towers, smart digital towers, whatever we're calling them right this second. So I thank you very much for everything you do. We talked about, the why, what, why, when, how, what's next. In this part 1 series, we talked about, future technologies, human factors. I think there was a lot to digest. As Connor said, we have some questions that we're going to hold the answers for to our next workshop, which is going to be part 2 in 2 weeks, same time, and it will focus on technology and enhancements. So I hope you all will join us then, and I'd also like to thank Helen Parker and Rob Howell from CANSO in our Amsterdam office for their support. Thank you very much. Well done. And with that, I think that's it. I think Helen has the last word, and we hope to see you back in 2 weeks. Thanks so much.
As always, Colleen, I do have the last word, and thank you very much. And based on what Connor said, yes, I can confirm we can follow up with some answers to the outstanding questions, which we can share at a later time. So thank you, Colleen, thank you, Connor, and thank you to all our speakers today and for everyone who attended. Once you leave today's webinar, you will receive a survey, and we would appreciate if you would complete that and provide your feedback. On behalf of CANSO, thank you for joining us today and enjoy the rest of your day.